Chi-square test in SAS. Introduction. Let's say, for example, there is a pharmaceutical company who is trying to test a new drug to treat a specific disease. Now, disease can be any kind of disease related to any therapeutic areas. So, this particular test you can use in any therapeutic area for any diseases wherever it meets the chi-square test system requirements, right? So now they are conducting a clinical trial with two treatment groups. Say the treatment group who is receiving the new drug. Now the new drug is not launched into the market. They are under the phase 1, phase 2, phase 3, phase 4 clinical trials, right? So this is what is your treatment group. So say for example, I have this treatment group who is under the rigorous testing purpose related to any clinical trial phases, and this is a control group receiving the placebo, right? So these are the two drugs which are used for treating a disease. Now after the trial they record whether the disease improved or did not improve in each patient. So here, placebo is nothing but just an empty drug. It does not do any effect in the patient's body. So it's just like a dummy treatment or a dummy drug that is given to the treatment. But the only intention is to ensure that the treatment group, how whether it has improved or it has not improved. So that is what is the concern. Now step 1, create the 2 cross 2 contingency table. So say for example, I have explained here is this is the outcome. Now why it is called 2 cross 2 contingency table? Because I am having two rows, right? And I am having two columns here, right? So which is drug and which is placebo. And here in row I have improved and not improved. So say for example, whether the drug has improved in how many patients? So that is 30. The number of patients 20 which are in placebo but they have improved, so that is 20. Now those patients who have not improved and who have received the drug treatment which is under the testing phase in the clinical trial, those number of patients are 10, and these 20 are those patients who are not improved and who fall under the placebo control. Now these are my these are my column totals 40 40, and these are my row totals, right? And this is my final total, so row total and column total should always match. So say 40 plus 40 is 80 and 50 plus 30 is 80. So this number should always match with the row total and the column total. If it is not matching, that means there is some discrepancy in this each and every cell, and usually it will not be that situation. It will always match. So this is one example that you can understand for applying the chi-square test. Step 2, what is the research question? So we want to know whether there is a statistically significant association between the treatment and improvement. Now this is tested using chi-square test. Okay, so this is used by using this chi-square test of independence or the Fisher's exact test whenever the counts are small. Step 3, choose the test. Now here all expected cell counts are above 5. Now as you saw in the earlier table, all the cell counts they were above 5. So the chi-square test is the test is appropriate. Now say for example, if there are some counts which were small, then which is say for example less than 5, so in that situation we will use the Fisher's exact test. Now what do you mean by some counts? Some counts means like you will be having four individual cells, like say in the 2 cross 2 contingency table. I'm not talking about the row totals and column totals. So if any of the cell count internally, if it is less than 5, then we use the Fisher's exact test. Step 4, calculate expected counts. So here I've explained, here is the expected count for each cell is nothing but row total. This is the row total into column total divided by grand total. So if, for example, if you consider the earlier table which I had shown in earlier slides, if you count the expected for improved plus drug, that is 50 into 40 divided by 80, which now 80 is my grand total, right? So these are my counts for improved plus drug. So those cases will be 25. So here that cell count is this. So this is how you calculate the expected counts, right? By considering the row total and column total. So this is the presentation of the table that you have to prepare manually if you are interested to calculate the chi-square test. Step 5, chi-square statistic. Now here the chi-square statistic is nothing but summation of all observed cases minus the expected cases raised to 2 divided by your expected counts, right? So O is nothing but my expected count, E is nothing but my expected count, right? So here plug in the numbers, which is the chi-square test. So here I have presented this physically, 30 minus 25 raised to 2 divided by 25. So if you want to really understand how to calculate the chi-square test manually, now since this is a 2x2 consistency table, I don't think it will take so much of time. So what you can do is you can manually try this, and you can get this number, which is 5.34. Now this 5.34 is nothing but the value of this chi-square statistic. Step 6, determine the p-value. Now whenever we consider the degrees of freedom, so like say for example I have two treatments, treatment group and the placebo. So I have two parameters. So that two parameters minus 1. So here is my degrees of freedom. So because the reason is this one particular parameter is dependent on another parameter. That is why we exclude that minus 1. That's the reason we get the degrees of freedom as 2. So even if you consider the two rows, say for example improved and not improved. Now the improved cases are always dependent on not improved. So if you don't have that not improved cases, you cannot calculate the improved. So in such scenario, always one parameter is always dependent on other. That is why we calculate this, how we calculate the degrees of freedom. That's the reason we do minus 1. Now using a chi-square distribution table or a power calculator, we calculate the p-value. Now this is my chi-square statistic. This is the chi-square value from the earlier slide, which is 5.34. Now I want to calculate what is the probability of this chi-square test greater than 5.34. So this is approximately equal to 0.021. Step 7, interpret the result. Now since the p-value 0.027 is strictly less than 0.05, right? So here it is strictly less than 0.05, which is a common significance level that we use, that is 5% level of significance. So we reject the null hypothesis. Now since there is a statistically significant association between taking the drug and a improvement, so that is what is the conclusion. So here we reject the null hypothesis because the p-value is 0.021, which is strictly less than 0.05. Hence, we conclude that there is a statistically significant association between taking the drug and improvement. Now, if you want to understand the SAS program, I'll just quickly explain you the SAS program here. So, the step 1 is you enter the data. Now, this is my data step. This is my input statement. So, this is the input statement. This is the treatment. This is the outcome, and this is the count. So I will have 3 columns. So this is first column, second column, and third column. So the first column represents your drug, that is treatment. Your second column represents your improved, not improved cases, and this all is my counts, which is 30, 10, 20, 20. So you can always manually enter this data step in your SAS program, and you can yourself see that you will get three columns and 4 rows. So now coming next to the step 2, which is create the contingency table and run the chi-square test. So we use here the proc-frec procedure for doing the chi-square test. So we take this data, which is equal to efficacy here, The table says treatment into outcome slash chi-square. Now this chi-square is a particular statement that you have to use in the table statement, so that the SAS procedure or the proc-frec, it will perform the chi-square test. Now this is treatment into outcome. Now if you don't put this into, you will not get the result. Again, if you don't put this slash, you will not get the result. And then this is the weight. So what is the weight of this two variables, that is first variable and the second variable? So my weight is nothing but my count. So each and every syntax or the options, you should be able to first understand how does this proc freak runs. Only then you will be able to understand practically, right? So each and every statement is very important. If you don't put this star, you will not get the result. If you don't put this slash, then also you will not get the result. You can try it out yourself. And again, you have to put the character symbol in front of the character variable. So this is also, outcome is also the character, so it's always essential to use the dollar sign. Again, here the count is numeric, so you need not put any character or a dollar sign, so it will just take automatically the numeric number. So you can try this if you have the access to your SAS software, which is available on the academic version on the platform. Now bonus here is adding Fisher's exact test. Now in the earlier proc-frec statement, there is a table statement, right? So when you perform this treatment into outcome slash chi-square, along with this chi-square, you can also give the Fisher option, so that you will get both the results. Now if you want to compare the chi-square and the Fisher test parallelly, even though the cell count is not less than 5, you can still use both these features and you can get the result. So if you don't want to use the chi-square, and if you want to put only Fisher, if there is any of the cell count is less than 5, you can also use that, and you can also use this together. So you can try out practically if you have the access to your SAS academic version.
Please like, share, and subscribe to my channel. Leave a comment mentioning any topic that you want me to make a video. Looking forward for your positive response. Thanks for watching. Please like, share, and subscribe. Leave a feedback comment. Many thanks for your support and having great connection.